in the midst of a pandemic, it is important to note that the United States of America can still do stunning achievements. We saw that recently when we launched Perseverance to Mars. We saw it when we launched Bob and Doug on a SpaceX Falcon 9 rocket in a crew capsule called Dragon to the International Space Station. Then we brought them home safely. We can do these things, and we can do them safely, even in challenging times. And now we're building the most powerful rocket in the history of humanity that will take not just the next man, but the first woman to the moon by 2024 in the Artemis program. This program is commercial in nature, but it's also international in nature. And so we're very grateful for our partners that are building the FSB boosters so that we can ultimately achieve the objectives of our nation and, in fact,
Here at the Northrop Grumman's Promontory, Utah facility, we manufacture the solid rocket boosters for NASA's Space Launch System that will launch Artemis missions to the moon and beyond. Today we are testing one of those boosters in our Promontory test area. The SLS booster motor measures 167 feet long and 12 feet in diameter. We have successfully completed 5 previous tests to qualify for flight. This test, dubbed Flight Support Booster 1 or FSB-1, will evaluate new propellant materials and verify that all ballistic requirements of the motor are met. Preparations for this test began in March. The first of 5 segments was installed in the test bay in April, and the last one completed installation in June. The motor has been cold conditioning to a target temperature of 60 degrees Fahrenheit to 70 degrees Fahrenheit over the last several weeks. All of our large solid rocket motors undergo ground tests at our Promontory site before ever flying. In addition to holding this 1.6 million pound motor in place, the structure houses all necessary electronics and instruments needed for motor firing and gathering performance measurements. Ground tests such as these give us the opportunity to collect additional data parameters on the performance of the motor that would not be possible on a flight. Upon ignition, the motor at this target temperature will fire for about 122 seconds and produce 3.6 million pounds of thrust. The 5-segment SLS rocket booster is the largest solid rocket motor in the world.
3, 2, 1, fire. T plus 5 seconds. T plus 10 seconds. T plus 20 seconds. T plus 30 seconds. T plus 40 seconds. plus 50 seconds. T plus 60 seconds. T plus 70 seconds. T plus 80 seconds.
Central Support Systems Operator, enable the deluge CO2 and quench tool controls.
Enable.
T plus 90 seconds.
Open the accumulator enable valve.
Accumulator is enabled.
T plus 100 seconds. T plus 105 seconds.
Activate aft deluge.
Activated.
T plus 110 seconds.
Activate forward deluge.
Activated.
T plus 120 seconds.
Activate head and CO2.
Activated.
Activate quench tool command forward and aft CO2.
Activated.
T plus 170 seconds. High-speed data operator, stop recording.
High-speed recording is complete.
Roger. Low-speed data operators, stop recording.
Low speed data recording complete.
Roger. Post-fire crew, report to the instrument room. Post-fire crew, report to the instrument room.
Boosters are larger for SLS because we needed more thrust at takeoff. This is a much larger rocket. Trying to go to the moon is a much harder job than trying to go to the space station in terms of the physics of the problem. So we produce a lot more thrust than we did under shuttle. And so we added a fifth segment in both boosters, and that gives us the thrust needed for these Artemis missions. So we test these in a remote test site out in the desert, and we do that for safety reasons. In fact, we watch them from 3 miles away, actually, from the test itself. But it's in what we call the T97 test stand. Northrop Grumman does these tests for us out at their Promontory plant in Utah. They've done these for years and years. They use this same stand under shuttle, though we've had to do some changes to it for our booster for SLS because it's larger. What excites me about these tests is the sheer scale and the magnitude of a 150-foot solid rocket motor firing in the desert. It makes a lot of noise, a lot of fire, and it gets us really good scientific objectives too.